today's presentation, the baseline protocol meets enterprise supply chain. Really fascinating topic, really fascinating technology and methodologies that are being brought to emerging technology. And just real quick, obviously Envision Blockchain, we are a Microsoft partner in the space. We're a gold partner. Proud Enterprise Ethereum Alliance members and participants, of course, certified through the Linux Foundation and Corda partnered and certified as well. So we play a very active role in the industry, and now we play an active role within Baseline as well, as it relates to the open source, which we're going to spend some time learning about here today. At the same time, I'd like to take this opportunity to go ahead and introduce Karthik from Ernst & Young, who's actually on the call here joining us today. So without further ado, Karthik, please feel free to introduce yourself and to explain to everyone here a little bit about who you are, what you do, and your participation with Baseline.
Sure. Thanks, Jason. Hello, everyone. My name is Karthik Solipuram. I work with Ernst & Young, aligned with the cryptography and distributed infrastructure practice in Ernst & Young. Other words to say, I'm part of blockchain practice at EY. Been with EY for about 6 years and in the blockchain space for the last 3 to 4 years. I play the role of a platform engineer and also lead some of the research efforts within the firm. My role on Baseline was that of the tech architect and solution lead. Got a chance to work with many bright co-developers from Consensus as well as Microsoft. And right now I play the role of one of the technical members on the technical steering committee and a maintainer, one of the maintainers of the GitHub repository. Back to you, Jason.
It's really impressive, Karthik. Thank you very much, and I really appreciate your flexibility and of course ability to be here today to properly convey the various details that we have in store, especially taking everybody through the demo that'll be towards the end. So looking forward to maintaining everybody's attendance and keeping everybody present. And again, we'll be taking questions towards the end of the presentation. But in the interim, my name is Jason Pansis. I'm the co-founder of Envision Blockchain Solutions. And at the current time, I'm sitting as the co-chair for the Enterprise Ethereum Alliance Supply Chain SIG. And that's, supply chain is something that I hold dear to heart. And passionate about, and really have taken a unique approach within the enterprise blockchain space as it relates to supply chain, which has drawn me to that SIG position right off the bat. But at the same time, the other co-founder here at Envision Blockchain, Daniel Norkin, he's actually the delegate who's sitting on the specification steering committee within the Baseline initiative. So we have a very interesting and diverse set of representatives between Envision Blockchain and Ernst & Young, and it would be unjustified to call out everybody else who has played a very active role in ensuring the progress that Baseline has seen in just in a couple of weeks since it's been announced, let alone of course, Consensus and Microsoft and Ernst & Young being the founders. They've made some incredible headway since the start of this project. So again, Karthik, thank you so much for joining today. Just a brief plug, Envision Blockchain, we're a consulting and custom application development organization. I'd say you would consider us more of the enterprise blockchain systems integrators, if you will. And just at the high level, we perform an array of services, as you can see there on the left, with respect to consulting and custom development services as it relates to various different components of the modern cloud. So obviously with a unique focus on blockchain, we obviously pay a very close attention to modern cloud on-prem solutions and take organizations through the full gamut and from a consultative approach and custom development, leveraging all of the different modern cloud solutions. And on the right, you can see that we have an array of workshops as well. So there's a specific approach and various different methodologies that we use and incorporate within our professional practice to facilitate various different roundtables and exercises that we take our clients through to properly extract and derive the information that is specifically needed to help with our custom application development practices, leveraging the various emerging technologies we deal with. Obviously, the baseline protocol there on the upper right and how enterprises use the Ethereum Mainnet is really what we're going to be focused on here today. And we'll get into, what our workshop entails towards the end of this call and where you can, of course, locate it. Enterprise supply chain has had some interesting challenges without any sort of emerging technologies, and has had an array of demands that has come into its evolutionary state as a result of globalization. So when we look at the various array of, I guess, challenges that supply chains have, at first we kind of take notice that there's various different rising supply chain and operational costs that we begin seeing as a result of globalization. So when we take a look at international supplier sourcing and the various different suppliers that a supply chain can now have as a result of global communications, peer-to-peer communications, and this 24/7 worlds that we really live in, it can complicate various different enterprise processes in the way we begin procuring or various different buyers crossing or overlapping communication between either suppliers and even internally within any one specific enterprise silo as it relates to specific information. And once we've even gotten past that sort of complexity, we wind up now moving forward in the supply chain where once we have delivery of specific goods and specific inventory, we begin the sales channel, and as a result of the various different solutions and e-commerce platforms, we're not necessarily vending or supplying to any one specific organization anymore. We could theoretically be supplying and vending through various different B2C consumer applications for e-commerce, and at the same time, wholesalers may be supplying through different e-commerce type platforms that are B2B. So fulfillment has had its complexities as a direct result, and that all leads to various different complexities as it relates to making proper decisions. And these specific decisions in a timely manner are very costly. I can tell you firsthand, dealing with ocean freight shipping, air freight, inland transportation, rail, all the above, to understand where inventory is, inventory management, for example, and to understand when shipments are being redirected and estimated time of arrivals are critical, let alone the various different port charges that may be directly associated to customs clearance or port strikes, all of the above. And what winds up happening is we have data that's siloed in various different supply chain entities or organizations, let alone even if it's even in one enterprise organization, you may have siloed data. which as a result diminishes our ability to see where different product or inventory may be, and we can't get proper reporting in time to make the best decisions. And it seems as if the world has just randomly started to demand, efficient delivery times and quality products. But in fact, the evolutionary state of the supply chain and the fact that we've globalized and the fact that we've been able to create more efficient technologies has allowed for that sort of a luxury where the end consumer, when they purchase something through an e-commerce platform, let's say like Amazon, and now they have Amazon Prime, they want Amazon Prime now. Literally, if when they click the button, they want it not only now, they want it not only today. Essentially, they want it handed to them, and realistically, they want the product to be perfect. So time as money is an old statement and could never be more true. And as a direct result, when we began experimenting a few years back with enterprise supply chain as it relates to blockchain, what happened is we had this huge hype cycle, and since we've seen this diminishing hype. And we have this quote here from an article that was taken from Gartner, where an individual said that it's impossible for organizations to identify and target specific high-value use cases, of course, relating to blockchain technology. Instead, companies are forced to run multiple development pilots using trial and error to find ones that might provide value. Now that's very, very interesting, and obviously leads to a lot of different questions, and clearly leads to high overhead and potential loss. So privacy has been and always will be a major factor as it relates to business processes, business data, so on and so forth. Of course, governance is always going to be a factor. Costly barriers of entry as it relates to emerging technology, and barriers of entry as it relates to getting involved in any sort of supply chain in general. And of course, network value as it relates to how strong your supply chain is and its various participants. So as we begin to break this down, we can clearly see the elements that directly impact or concern privacy as it relates to intellectual property, as it relates to data privacy, the various different business processes that belong to any one specific entity, and of course, their various suppliers or vendors. That's a huge concern. With respect to governance, as we begin taking a look at establishing these networks, and dealing with various different consortia, all I think about is the days, the years, the months, the time in legal fees, in kind of bucking the trend, so to speak, and trying to get technology to work amongst the various different network participants that may already be competitors. So you have various different concerns within governance, participant rights, software and network management, how often do we iterate, who's in charge of the various updates, and of course then you have the participant politics. Costly barriers of entry, we're talking geographic regulatory variables. What's legal in this country may not be in another country, which lead to more legal challenges and potential barriers that may prohibit network participants. Then you of course have the concept of redundant networks. Well, if this company is doing it, then why should I? And you don't even know if you'll ever be part of that network to begin with, and who's even doing what. You have no visibility. The various different integrations, and obviously change management as it relates to the operational risk. But most importantly, there's no value with missing suppliers in any network. And that further reduces value when you eliminate free market options. that's the whole point of globalization. That's the whole point of having these vast and robust supply chains, to draw and have your options not limited as it relates to the various suppliers and vendors that you can participate with. So as a direct result of this diminishing hype, we've now reached this state of the blockchain hangover. And in the upper right here, we have this quote that basically says that Gartner predicts that 90% of blockchain-based supply chain initiatives will suffer blockchain fatigue by 2023. On the left-hand side, we clearly see, and we've just reviewed, all of the various different challenges that we've been needing to overcome. And on the right, we have some Advil and we have some Gatorade to help us overcome, this blockchain hangover that we've just established. And, moving forward, today's conversation is really going to focus on solving these specific challenges. And realistically, we're really focused on enabling confidential and complex collaboration between enterprises without leaving any sensitive data on chain. It's a very interesting concept because we haven't necessarily been looking through that prism this entire time as it relates to blockchain and supply chain, and of course various other industry verticals as well. So let's introduce the baseline protocol, a way for enterprises to use the mainnet as middleware without compromising corporate information security practices. I'm going to briefly just run through this. It's a lot of text, but a lot of this, is all open source, which is an excellent thing, and you can go and reference all of this material, and we'll show you where towards the end. But essentially, at the high level, systems record integration 2.0. We're basically taking a brand new approach and trying to establish a way to reduce the high cost of high cost barriers to various different networks, and paying very close attention to mitigating the risks of data privacy and security. Stealth versus privacy, a very interesting concept as it relates to, for example, tokenization. We're not interested in keeping your data necessarily on chain. That's this whole concept of baselining these systems of record. Likewise, we needed to establish some sort of common frame of reference. And in this specific case, and Karthik will get into it just here in just a second, but the Ethereum Mainnet happens to be the common frame of reference that the baseline protocol has introduced and is currently leveraging, but is of course not limited to the Ethereum Mainnet. It's an important statement that I'd like to iterate, but happens to be right now the most effective and reliable common frame of reference that we've currently identified. And of course, last but not least, understanding that we're trying to keep business as usual, and this concept of baselining requires these various different systems of records, which are simply just state machines, and this is nothing new. These are the ERP systems that we've spent millions of dollars on, CRMs, EMSs, FMSs, and just various databases in general. So realistically, blockchain is exciting. I mean, boring. This is the whole point. Blockchain is and was a hype, and realistically, let's bring it back to reality. Let's keep things not exciting. Let's keep things boring. Let's make sure that we look at this new emerging technology, so to speak, as middleware. So the first component here is to ensure a local system of record is baseline compliant. We're talking about state machines. Once again, we should be able to do this without any problem in the future. I'm sure that everything, if they aren't already, for sure will be. And state machines aren't necessarily limited to ERPs. They could theoretically be other private blockchains. Likewise, from there, what we're talking about after we've established this system of record and its baseline compliance, we can then begin setting up the various different work groups, and we can begin sending messages, off-chain messages, secure off-chain messages. In this specific case, just like Karthik will get into, the reference implementation uses something called Whisper, but you could use, email messaging theoretically. At the same time, the whole point now is to prove the data and the workflow consistency that you have in your system of a record, which we call now baselining. And once you can secure that and prove that, well, now you can use the mainnet to prove that your system or that data or that workflow has been baselined successfully, and everything can match. This is when everything winds up being put onto this mainnet or this this is the reference. And of course, tokenization is an interesting concept. We're not going to get too much into that, but this is a huge area of opportunity as it relates to decentralized finance, where we're not interested, once again, in putting any sort of data into tokens. We can begin leveraging the baseline concepts of proofs to basically have an ERC 721, for an example, or a non-fungible token host that sort of information, just that hash. So the baseline protocol is a series of open source libraries. And I just want to reiterate that blockchain isn't the issue. It's boring. At this point in time, we're looking at it as, as just basically a reference, a common reference. In that our approach since the beginning may have been off. So these are the various libraries, from privacy, messaging, mainnet libraries, querying API libraries, and of course, a queuing system. And what we're taking a look at here is, in the first line, you see Radish 34. In this specific case, it's leveraging Socrates with respect to its zero knowledge proof. If you have another application that you'd like to use and develop leveraging the baseline protocol open source libraries, you can feel free to use whatever you'd like. You have your choice. The same will go for messaging. The same will go for mainnet. I mean, at this point in time, Ethereum Mainnet is the current choice, but that is up for discussion in the event that anybody has any additional thoughts, solutions, so on and so forth. Again, this is open source. Likewise, querying API libraries, and of course, the queuing system. Moving forward, I'd like to introduce Karthik to really go into the details of the reference implementation that leverage the open source libraries that we're calling the baseline protocol, named Radish 34. And I'd like to hand that off to you at this point, Karthik.
Right. Thanks, Jason. So as Jason was pointing out, one of the key areas, or some of the key drivers that also led to formation of the baseline protocol was the driving challenges that we've seen in one of the common industries where blockchain is usually applied, which is supply chain. We see that in most of the communication is more or less bilateral, whereas in some cases it can change in terms of the communication being multilateral, where one party needs to disseminate multiple messages either of the same content or of different content to different folks or different participants or different recipients. But regardless, from a procurement point of view, some of the challenges we identified for an implementation of a procurement solution was any bilateral communication that can be handled and that does not require the use of blockchain or does not have a business incentive to use blockchain need not do so. They can still be managed using a private communication channel. So this applies to, for example, requests for proposals, where requests for proposals traditionally more or less are done via email or some sort of secure point-to-point communication. In the case of Radish, as an implementation, we used Whisper as one of the primary areas in which decentralized secure communication can still happen. And there's not a necessity to have any transaction or overall change to the blockchain or the mainnet itself. Then comes into the aspect of the agreements. Agreements are business relationship terms which are mutually attested, and also which require that both parties are legally it's required that any parties entering into an agreement are indeed agreeing to the terms of the agreement, and in such a way that there are other concerns around revealing the counterparties involved. Like, for example, in a procurement use case, it can so happen that a buyer or a publisher of any agreements or RFPs for that matter, it would be okay with them publishing the information, but it is not okay for the suppliers who are responding to those buyers to be revealing their identity as to what their information, as to what they have responded with, or as to what their direct communication is with the back to the buyer. But at the same time, we need to make sure that all that interaction is verifiably provable. Finally, then comes into the aspect, adding another layer of complexity over there is agreement terms are more or less, we can consider static for the period of time. But when there are other changes that happen, like when there is business logic or some business rules that stipulate how the agreement terms should be applied to a certain piece of data, then comes into picture the use of data, the legacy data, and the transformations on that legacy data in such a way that the business logic is accurate, but at the same time has to follow the privacy constraints of not revealing the aspects of the business logic itself, that is the calculation itself, nor the inputs to the calculation, just that the outputs of the calculation should be verifiable and provable. With this, I'll flip over to how the architecture of Radish 34 looks. And as we go along, I'll walk you through some of the key components of the architecture, as well as a representational workflow as to how we applied it for how we applied all this complex to system interactions as applied to this procurement use case. At a high level, the workflow, as we were discussing the challenges before, like around agreements, business logic validation, using the mainnet in the right manner. To sum up, the representational workflow that we're trying to solve is a buyer and supplier engaging into an RFP through an ordering process, where a typical process covers buyer issuing an RFP, a supplier responding with a proposal, buyer issuing a contract or a master service agreement in response to sort of stamp or record or start the ongoing procurement process. And then the beginning of ongoing procurement process is a purchase order, wherein the purchase order has to be issued in such a way that the price of the purchase order is based on the terms mentioned in the or terms agreed upon in the master service agreement. As a reference, the terms that we are using at this point is a very relatively standardized volume discount structure. What I mean by that is relatively standardized volume discount structure problem, wherein buyers and suppliers typically engage into some sort of a standardized volume discount structure where by means of business or by means of the relationship, the discounts are applied depending on the volume ordered over a period of time. So we've taken that as a term, a static term, or rather a term that needs to be monitored as purchase orders are issued. So every subsequent purchase order is to be issued based on the volume consumed in that based on the tiering structure that has been declared during the terms of the agreement being in place. So that's the overall workflow. So I'll go over the components that we have used. So in this picture, we see the different libraries that Jason was referring to are something we started off in terms of a usage in the Radish 34 implementation. A very high level representation or function a functional representation of what the different services are in Radish it's a Dockerized infrastructure wherein it's a single tenant based Dockerized infrastructure wherein each So wherein each microservice is containerized, or sorry, each microservice is represented by these circles. And you can see that there is an API service, which is which we use GraphQL libraries. The choice of GraphQL was mainly so that it could enable easier UI or external integration, but at the same time has a querying layer to be able to run any data transformations or direct before interaction with any form of web services. Then we have the API in itself leverages a lightweight open source queuing library called BullJS. In reality, any other library could be used, but for the sake of the use case and for the sake of the proving the principle of, or proving the principle of having workflow steps that could be modularized, we've used a lightweight queuing system called which is run by the BullJS library. Inherently, the BullJS library also, for the sake of the BullJS library, we also use a Redis DB instance to capture any interaction with the queuing system. The queuing system essentially orchestrates, sitting in the API, orchestrates interaction with a secure messaging service, which is the usage where we used Whisper, and a ZKP or ZKP service, which is using a specific form of a toolkit called Socrates, which deals with a specific form of ZK Snark technology under the ZKP family. So this is the overall architecture, and all the contracts that we deal with in terms of the business interactions or any interactions with the mainnet are captured over here. We try to use as much as possible the open standards out there in order to leverage the existing EIPs or promote the existing EIPs, so to speak, so that they could become proper standards or extensions of standards that could be relevant for different industries as the protocol keeps churning on. The registrar contract here in reference is basically a standard called ERC 1820. It is used for registering, or it's basically in the scope of Radish, or as Radish implements it, it's a contract which is a client or a wrapper slash connector to an ERC 1820 global registry. So any new contracts that are added are registered automatically with the global registry for easy lookup, and also to maintain some form of interface standards. The types of contracts we have are the organization registry contract, more so is more like a global phone book, or equal, as in one of the previous slides Jason was explaining, we had seen that the the workflow group and how work groups are set form the basis of how business relationships are formed. So we identified that as one of the areas that needs to be at least abstracted out and represented in a state on the mainnet, and that's where we used org registry contract, which is more or less a name registry contract, the standard name registry contract that most of the smart contract developers are aware of. But this organization registry contract is also to specify a certain interface for interacting with it, like as extensions could be made. This could be added with other aspects of permissions or access control management in the way, or even wallet management or fund management in the way that this organization registry contract acts. But in turn, it's also integrated with the global ERC 1820 contract. Similarly, we use a pair of shield and verifier contracts. The usage of this is inspired from Zcash as well as Nightfall, which effectively use how token transfers could, or any form of transfers of funds between parties or between two entities on the mainnet can be hidden by using a concept of shielding of transactions, where every transaction that represents a transfer of balance represents a private transaction, and therefore goes through a shielding layer to be able to mask the relationship between who is sending how much to whom. And in the same way, we have extended that transfer concept, in this case for managing agreements and managing business logic in such a way that anyone managing the business logic on behalf of someone else, or whenever in the context of the Radish use case, whenever say a buyer intends to send an agreement to a supplier, that interaction or that information transfer or that information communication, we handle that through the shield and the verifier contract pairing. Finally, we have a token registry contract in place. This is more like a standard token interface. It could be an ERC20, it could be an ERC721, or it could be an ERC1155 multi-token. It's basically to represent any form of tokens or any form of business assets or business processes that have monetary value and satisfy all the other principles or best practices of what could be tokenized or what should be tokenized. Overall, the idea is that this is as we developed Radish, the idea was that there are components in there that are reusable and that could be extendable to other use cases. In such a way, baseline protocol is the creation or formation of such practices or such libraries or toolkits. Just to show an additional reference, it's just to indicate that the extent from an extensibility point of view, the Radish ecosystem or the baseline protocol extension could also apply to any hosted environment or from infrastructure perspective, but also from a functional perspective could be extended as well. That's the overall conceptual representation of how we came about with the different infrastructure components. I'll quickly go over the different sub-components that are there from within each of the layers. The API is pretty much the gateway or pretty much the overall orchestration layer, which has various modules or various separate services, so to speak, to interact with the application services or the UI layer or the external integration layer, so to speak, a blockchain interaction using Ganache or for testing purposes or Robston for testnet purposes. And it houses this library or this components of the various contracts. Similarly, the privacy components deal with the Socrates service, secure messaging deal with Whisper, and finally data management deals with any form of data services that are there. We try to highlight some of the components which can undergo modification and which could be readily used as is. The ones in light green are the ones which are more like modifications or extensions that could be built in. Like for example, in Radish, there's no authentication to allow for custom authentication libraries or packages to be used for authentication authorization circumstances. And similarly, queue management is an example of how it could be further extended. In the same manner, this could be extended to the rest of the stack. This is a functional representation of the overall Radish implementation. I'll go over. We have about 15 minutes. I'll quickly go over. To leave time for Q&A, I'll quickly go over a representational workflow of how we managed the various system-to-system interactions. In terms of how we have represented this or how we have implemented this, we are overall using a workflow-based system or a queue-based system. The idea is that when buyer issues an RFP, it's more like a task, or from a system interaction point of view, it's a task of an API interacting with the queuing system to be able to issue a payload, and the same applies to the response event from the supplier. So more or less, this job of issuing an RFP and receiving a response is a composition of queue tasks that go from interaction with Whisper to be able to inject a payload, Whisper sending the payload, and the supplier or the recipient system detecting the payload and updating to the local DB. So this sort of task or the overall workflow step is something that we have broken into separate tasks in terms of system integrations, the actual service invocation, and the acknowledgement of that service response itself. So in such a manner, we have started with representing how a basic RFP communication, which does not warrant involvement with blockchain, could use a queuing system and have a workflow representation. Similarly, for baseline, for MSA, what this things start getting somewhat more composed. We start with saying that we want to be able to sign the MSA document, where commitment is basically a hash of the document. So we are signing the particular commitment, and that signed commitment is again sent to the supplier. Supplier on receipt does the same process. So here, a slight modification to the previous steps, in the sense that now there is a signature process involved. The signature process involved here is slightly different from quite different from the traditional ECDSA schemes. This is more so to be able to verify the signatures done by the signatories in such a way that the identity of that signing party is never revealed. So that's where we start the invocation of the Socrates service. So we generate proofs to say that the hash is well formed, in the sense that the hash of the document is indeed the hash, as we can compute it even within the off-chain component of the Socrates service, and also whether the signed object or the signed MSA is indeed signed by the intended supplier. Once we generate those proofs using Socrates, we then verify them on chain using the shield and verifier pairing. And this essentially proves or verifies the fact that these proofs that are generated are accurate. And we provide this information to the supplier, and supplier at that point of time can verify the fact that wherever that particular hash has been stored on the chain is indeed the correct hash, and can also validate based on the transaction receipt of this on-chain verification. This is basically the overall process flow or from a system sequence diagram perspective as to how we have modeled this overall implementation itself. So just like how MSA works, we can extend the same indication even towards a purchase order. And as we built this, we identified that there are several components in this that stem from our understanding or our agreement on how we want to have the baseline protocol structured model from point of view of extensibility and scalability. I'll take a brief pause. I just wanted to make sure I have a time check with others to see if we should open the floor for questions.
Just want to reiterate that we are going to open up the forum here for a couple of quick questions. But this is an open source initiative, as we have described, which of course would include an open source GitHub repository that forward you can kind of see that we have an array of documentation which includes various areas of information or libraries of information from the contributors guide through the reference implementation Radish 34, and of course all of the information related to the baseline protocol. Most importantly, because this is a huge area of opportunity for the world to really come together and really build out a unique and once again boring approach to leveraging this emerging technology that we really rarely even discuss. It solves an array of enterprise challenges, and getting involved and building out this open source protocol is really why we're doing this. We really want to make sure that the community is there, the community gets involved. We want the innovation, we want the participation, and coming from an area where I know my colleague Dan Norkin, who sits within the specification, on the specification steering committee, and of course Karthik, who we've had the pleasure of hosting here today, has properly explained the various different workflow diagrams and architecture as it relates to the reference implementation, Radish 34. He sits on the technical steering committee. You know, it's very important to all of the above participants to gather your feedback, to of course, you know, further develop and enhance this open source protocol. And of course, just a brief plug with respect to Envision Blockchain. We do have a workshop that is listed in the Microsoft Azure Marketplace. You can access this at, you know, the link below, or if you just went to the Azure Marketplace and just search for Envision Blockchain, there is an array of services that we offer. But realistically, you know, you should be able to find the intro to the baseline protocol workshop, you know. And most importantly, I mean, just with respect to this being open source, you can go on your own to the GitHub repository, you know, start off by Googling the baseline protocol, and you know, you will find an array of information. Tons of great minds have put a lot of work and effort into you know, making this happen, and have really structured the governance and the way that you know, this whole open source set of libraries are being managed. I'm going to leave that and open the forum now with a couple minutes left for people to really dive in, ask whatever questions. You know, I think it's important that in the event that anybody wants to see the demo, you know, we can stay maybe a couple minutes afterward, but I guess in the interim, you know, if there are any questions, we'd like to open up the chat here.
Hey guys, I just wanted to quickly mention that there was a question that came into the Q&A, and I'm just going to repeat this over here for the purposes of the recording, because it may not be able to go ahead and be put into the chat. But essentially, you know, if anybody wants to contribute and they may not know exactly what should they contribute, I would say that a good place to start would be to go to the repo and to open up the issues tab, and you could see where the current areas of the opportunities are, and then just to call some out. And I think Karthik can definitely elaborate on this. Some of the areas of improvements and the extensions are with APIs, with different zero knowledge proofs, with different smart contracts. Do you think that you can just elaborate on that just a little bit, Karthik?
Yeah, so I think we've started to, as Daniel was pointing out, we started to point out some of these as some open issues for others to be able to work on, or also even pick up where there's already a basis to pick it up from. So in the sense, the library, the various issues that we opened, there is a working model for it. It's more like what extensions could be done, or what more optimizations could be done specifically. So for example, for smart contracts, we have used basic ERC 1820, and then we have used organization registry, and we have used organization registry, and we have also used the shield and verified contracts in the most elemental form. So if there are any improvements, like for example, if there's a decentralized identity management approach to how we want to manage organization registry, that's a plugin that could work well with the ERC 1820 acting as an umbrella or a global registry of sorts. Similarly, there are optimizations that can happen in the shield contract or the verified contract, or even for that matter, how many shield or verified contracts do we want to maintain for a business relationship. Is it just one or two, or for every business relationship, or is it one big massive umbrella or registry of such shield or verifier contracts itself? So there are those are areas where we thought that it would be better for it to be developed a little more in terms of collaboration with the community, and also have community experts who are, there are many experts out there on decentralized identity management and identity management in general. So so that is one area ripe for change or innovation in general for baseline, and also for enterprises to adopt uh, uh, interaction with the mainnet. Similarly for ZKP or the services, we have identified that there are other, apart from Socrates, there are other tools which may be more of interest, or which are other options available out there in terms of how they work and how they operate, and also in terms of their overall performance and ease of use as well. So different libraries or different tools have their own nuances or their own sort of quote unquote complications in terms of interaction. But the way we try to build this is such a way that as long as we can build that as a good out of box RESTful interface, then the overall system doesn't get compromised in terms of the system to system sequence of events as well. So the areas where you see that there are improvements that can happen in Socrates are, how do we modularize those circuits in such a way that we can replace the hashing mechanisms? Like right now we are doing classic SHA, but there are other hashing mechanisms possible. And then there is also the aspect of security and performance. So in terms of testing it out, uh, or even improving the performance of the overall setup, because the setup itself takes some time, and depending on different types of use cases, the setup times may vary. So there is some amount of effort that could be beneficial over there in terms of either parallel computing it, or multi-threading it, or even for that matter having it as a good hosted service that could be managed by using good CI systems, or good Kubernetes, or message broker or orchestrations of usage of zero knowledge proof services. So those are the two broad areas, and I think these are like these are some things that we're trying to discuss also as part of technical steering committee, as would be what would be good features for the community to collaborate on to push this forward as well. Hopefully that answers some of the questions.
Yeah, thank you, Karthik. All right, and just one thing to mention over here too is, obviously, you may see that there's a lot of quote unquote issues that are in the repo. Just know that these are the agenda points essentially that the technical steering committee and what the specifications steering committee, these are essentially what the agenda points are, what we're going to be discussing. So definitely feel free to add, contribute, ask away. You can definitely see that there's areas of improvements, and we definitely want to take the voice of everyone from the community and to work together.
All right, well, listen, I thank everybody for joining. If you're interested in getting in touch with us, all of our information is, of course, listed there, and we'd be happy to hear from you.